TechZine Talks, where TechZine analysts bridge the gap between IT solutions and the people who need them. TechZine is your single source of truth. For more information and insights, visit techzine.nl or techzine.eu. Don't forget to subscribe to this podcast.
Welcome to a new episode of TechZine Talks, and this episode will be in English because we have English guests, and we are at the office of Eurofiber, and we're going to talk about quantum key distribution, Sander. That's a very interesting topic. So it's going to be in English, and we're going to talk about quantum. That's difficult for our listeners, I guess.
Why? I think you underestimate our listeners.
Yeah, maybe.
I mean, we will explain it very well, so hopefully. No pressure on the guests, but
we have guests to explain it very good because my quantum knowledge is not that...
So maybe introduce...
Oh, yeah, sorry. We're here at Eurofiber with John Slater. He's...
Josh Slater.
Yeah, that's what I said, right?
No, you said John. But
Josh Slater. He's technology officer at Qbert. And we're here with Mark Hulzebos. He's business innovation officer at Eurofiber.
Hello.
Good morning.
Nice to join us, guys, for this very important but I think a bit difficult topic.
Yeah, because I've heard several things about quantum key distribution in the past 5-6 months from at various events. It is being brought as the sort of a future of networking or at least communications or but I think the first thing we need to because quantum may scare people off a little bit, but it's the first thing we need to get clear is what exactly is quantum key distribution, or QKD, as you probably also call it, Josh. Yes, but we first have to go to the bumper because that's also very important. I always forget the bumper. That's a bit of a running gag in this because I tend to just want to get into what we were talking about. So the question again is, what is QKD?
Yeah, exactly. So QKD, like you said, so it stands for quantum key distribution, and it sort of falls into this field that's really developing and taking off now, called quantum communication or sometimes quantum networking. Right? I wouldn't say necessarily that it's the future of all of networking, but it's definitely going to be a part of the future of the whole communication and networking space. Yeah. And quantum key distribution, QKD, there's sort of two ways you can look at it. We can look at it from the quantum physics front, which is for many people very easy to understand. And we can also look at it from the kind of the application or the use case that's being provided through agencies like Eurofiber, for instance.
Yeah.
So at least on the physics front, what is happening and what people like at my company, Qbert, what we're doing is we're building boxes. These are really like network communication boxes that communicate back and forth with single particles of light at a time. And that's what makes them quantum. Instead of like strong lasers that you typically see on optical fiber, it's one particle of light at a time. And what that means is that, as you might remember from like high school physics classes or so, if anyone looks at or anyone interacts with in any way that single particle of light while you're communicating, there's a disturbance. There's some intrinsic disturbance, and our equipment can pick that up and we can see that.
Yeah, because that's one of the, as I understand it from my high school years, one of the key components of quantum is that if you look at it, it changes.
Exactly. That's right? Exactly right. Yeah. So what we do is we make boxes and we can put them at different locations, like a network that we have set up here at Qbert along with Eurofiber that we set up here in the Utrecht area around our offices in data centers, where those single particles will go back and forth between the data center rooms. And if anyone is looking at them or there's any disturbance on the fiber, we see that. Yeah. So that's what our boxes do. And then that can translate into a service called QKD, quantum key distribution, where we can use that to transmit a secret between two places. So what we're doing is using those single particles just to get essentially a random string of bits, which can then be used as a cryptographic key to encrypt any communication going back and forth between those locations.
Yeah. But you don't use any existing protocols for this transmission, or?
So we do the quantum part only to get the key back and forth. And then we move the key over to other network equipment providers like Juniper or Cisco, or the service provider like Eurofiber, for instance. And then they use the key and existing protocols and existing, I guess, software suites and hardware technologies to do the rest of the secure communication. Yeah. And that's why QKD and what we do at QBird, it's a part of the whole, will be a part of the whole communication infrastructure, right? It's a piece that fits into the larger package, the larger service.
Yeah, so just to be clear, you can use QKD with existing network protocols, with existing networks. You don't necessarily have to adopt a complete quantum network.
Exactly. Yeah, exactly. I mean, from the user perspective, you typically would not even need to worry about the fact that the devices might be doing something quantum, for instance.
No.
Yeah.
That should be invisible. I mean, that's always the best technology, right?
Yeah.
So, and in practice, from a Eurofiber perspective, I mean, what's your deal in QKD, right?
Well, we got involved with the guys from QBird in testing this in a real telco environment to actually evaluate this technology, and also interpret it into propositions that we can use for our own network security, but also translate to services that our customers would benefit from.
Yeah.
So it is a very interesting topic for us to get into, and it has been a steep learning curve for Eurofiber because we are essentially a fiber network operator and we are in classic networking.
Yeah.
So we're trying to bridge the gap.
Yeah, but just in terms of concrete, to make it a bit concrete, it is possible in theory and in practice to bend fiber, right? To bend a fiber optic cable and to have light escape.
Yes.
And is that a use case for saying, well, we need QKD to actually see
It is
whether somebody has done this, so we know if this connection is compromised or not? Is that one of the use cases?
We definitely are looking into that because, as Josh just explained, these single quanta of light that are traveling across our fibers are actually a great way to use as tamper detection method. And it strengthens our security portfolio if we can integrate these quantum connections into our networking proposition.
Yeah.
So
yes.
to make it a bit more clear, if you send data over the line and nobody looks at it, the quantum key stays the same. But if it's interrupted in between, then it changes.
Exactly. That's right.
So it's a real security feature.
Exactly. It's a security feature. It's a security add-on that you can put on top of the rest of your communication. That's right.
Okay.
Yeah, and from a Eurofiber perspective, we are looking into, quantum computing is a large subject, and it may be 5 or 7 or 10 years out, so it's probably very much out there still. But these kinds of quantum technology that QBird's built, they are available today. So there's a different horizon from our innovation perspective. We want to work on security elements in the here and now, and work towards quantum internet applications in later stages when these emerging technologies actually pop into existence. So we want to be ready for it.
Yeah, so you're using one specific aspect of quantum in this instance. So you're not because, like I said earlier, some people when they hear quantum, they think, oh, it's a 0 and a 1 all at the same time, and it's very, very complicated. But that's not what this is about, right? This is about a subset of a specific feature of quantum.
Yeah, exactly. I mean, it's exactly as you say. I mean, there's many more features and many more things that one can do in quantum and also in quantum communication and networking. And that is coming down the line, and that's on the tech roadmaps of our organization, QBird, and also Eurofiber, I'm quite sure. But today, the things that are the most production ready are really QKD, and that's based on just that very easy property we talked about at the start. Yeah.
And if you transport it to networks and it's handled by switches and, I don't know, SD-WAN connections, the key doesn't change either, because it does. The traffic does get handled by a switch or by...
Yeah, that's right. We can route through switches. We use optical switches in some of our devices just to do...
But then the key doesn't change.
No, correct. It does not change.
Okay.
Yeah.
But if it's firewall with deep packet inspection, it does change.
I think that would change it, because then you're taking that optical signal and sort of converting to electrical if you're doing that kind of inspection. Yeah.
No, but I think that's a relevant point, right? Because how point to point does it need to be, and how many judgment calls do you need to make in your network to actually see whether the key is still intact or not, right? I think that's from an infrastructure perspective. I think that's a relevant point, right?
The way we do it is we always do it end to end. So we make two kinds of devices. Some of them we call nodes, which are really the devices you put where you want keys to be established, where you want that secure communication link to be established. And we also make devices which we call hubs, which sit in the middle and do things like forming coherent quantum connections, which is maybe a different thing, but also things like the optical switching or optical routing of qubits.
But you can route it from, I don't know, Honolulu to Amsterdam, because it goes to many hubs before it gets here.
That's a bit far for us distance-wise.
Okay.
Distance-wise, we're limited to around 200 kilometers or so at the moment. And the reason for that is just because there are no things like optical repeaters that work in conjunction with quantum technology.
Yeah, so
they're coming one day, but this is still a ways off.
So why do those repeaters not work with QKD at the moment? Is that because they actually manhandle the key?
Exactly. Yeah, the conventional repeaters, it's because they effectively manhandle the optical signals, and they will cause disturbance in the qubits. Yeah.
But do you see any time in the future that the subsea cables will also be used for this?
I think yes. No,
because then you get a large distances.
Yeah, I think so. I mean, maybe there's two aspects right there. One is whether or not undersea cables are suitable, and they certainly can be made suitable. We have started some investigations with an undersea cable that goes from the Netherlands to Denmark, for instance, just high level, to see if this will work. But then the other side of the question, I mean, that's a small undersea cable, right? Netherlands to Denmark is not so long. The other side is whether or not you have active repeaters on this cable. And active repeaters, as they work in conventional networking, don't work in conjunction with quantum. But there are quantum replacements. There's a whole field of people, primarily in universities at this stage, but there are some companies that are trying to figure out how to make quantum repeaters as well. This will come.
From a Eurofiber perspective, I mean, we talked about the tampering so making it tamper detection or whatever you call it, making that possible by means of QKD. But are there any other use cases or practical uses for from your perspective for QKD?
Yeah, well, first of all, the quantum key generation aspect of this setup that is now been deployed is providing keys into classical systems, what we use with our vendors to strengthen, for instance, MACsec security in AES 265 with these quantum strings.
256.
256. Yeah. I'm sorry.
We get what you mean.
Yeah, I'm sorry. I always struggle. With these keys that we can actually quantum strengthen these types of communication, and we are now sending it into our Ethernet, our MPLS network through Ethernet connections to test different varieties of classical networking that we can use to bring this to our customers to further implement security in their networking setup. So there's a variety of options that we have there to go into quantum safe connectivity, but also we are looking into the evolution into the quantum internet. So once we have this hub and node topology running in our network, and we probably will get into some of the practical learnings that we did there. That we can actually use this topology to build out quantum internet in the future. So there's two ways to go about it.
But I'm wondering, many connections nowadays are encrypted, even after the NSA tapped into all the cables in the ground. Even Google said we're going to encrypt all the traffic between our data centers. They pretty use a high encryption. It's hard to decrypt and get the data out. So why is this interesting? Is it? I see this as a next step, but everything is already encrypted, and it can even be for very large distances. So, how many interest is there from corporates to use this?
Well, that very much depends on how you look at it, because we are very much in a testing phase where we want to engage with industry and vendors to actually evaluate this. How much interest would there be to work this into existing technology, and how much would it strengthen your security perspective? So that is definitely something that we would be interested in, and that is also what we have deployed with Qbert. Because taking it out of the lab and using this setup in a more permanent fashion allows us to experiment exactly with these types of use cases that we see for that.
So just off the top of my head, if you want to set up a call or whatever between the president of the United States and the prime minister of the Netherlands, for example, a very top secret, high sensitivity kind of call towards the future. Is that the kind of use cases that you would ideally also would like to use QKD for? Or I mean, I'm just thinking out loud.
I think the thing to remember in security is there is many layers to it, right? There's not just one solution. There's many things you have, and I've heard it described as like the Swiss cheese approach, right? You have many slices of Swiss cheese, and then you can block everything. Even if and all technology is suitable for certain, say, aspects of that communication. Right?
Yeah.
So I think because we're really dealing with the optical signals, this fits really well in the fiber network that's part of the communication channel between, say, the example you were just talking about, right? Yeah. So if the phones are optically connected to each other with optical fiber, this would make sense. But otherwise, like the first high layers of the security in the king talking to the president of the United States or so might be other technologies. But as it gets down to the real network, that low level network happening in between, that's where something like quantum and QKD would play a role.
Yeah, so it's part of the layered approach, as they also call it, like the layer cake of security.
The layered Swiss cheesecake.
Yeah. No, because that's because I always heard, especially from people that say that they understand how quantum works and what the implications are, is that, for example, AES 256 is already quite quantum proof, right? That's not really, you don't really need to upgrade that with extra encryption or an extra check to actually see whether that's a valid connection or not. So, is it necessary to do this?
Yeah, it's a really good point. But what is missing from that picture? I mean, you're completely right. AES 256 is a very good encryption standard and will be secure for many years into the future. And there are clear upgrade paths for this. But what's part of that entire picture is that AES requires users to have a technique to do key distribution between the locations beforehand. AES only works once you have distributed a key. Mm-hmm. And there are techniques, there are algorithms that are used all over the place in different layers for that key distribution. And the problem there is that these algorithms are where the weaknesses are. So we already know that these algorithms can be attacked with fast computers and especially with supercomputing clusters and quantum computers that are coming. That's where the attacks are.
Okay, and that's why you need,
And that's the part where quantum can come in and make a change.
If we get more power, the current encryption might fall.
Exactly. Yeah.
So you said, you mentioned a couple of times you were investigating. You're at the innovation office of Eurofiber, and you're at a company that's more or less also tied to the university, I think.
So Qbert was a spin-off from the Technical University of Delft, and in particular the faculty called QTech, the Quantum Technologies faculty.
So that gives me the impression that we're not talking about something that is production ready yet. Is that true, or how production ready is it, if it's production ready at all?
Well, QKD as technology has been around for a long time already, and the reason that we got involved with the guys from QTech and now experimenting with Qbert is that this particular technology that they have built is MDI, measurement device independent technology that should allow for any-to-any communication, which makes it more interesting for us. But it is also very not premature, but it is we starting to develop, which is the way that we talk in terms of experimenting and prototyping, but we are at a level where we could work together with Qbert tomorrow if we find a customer that wants to engage with this technology and wants to build a network, quantum safe connections that we can actually start tomorrow.
You can also you can already give a demo of it, right? So you can you can show how it works and that it works, which is also quite important.
We've had demos in the past. I mean, I think the last big one with Eurofiber was November or so.
Yeah.
And while at the moment we don't have a lot of systems sitting on the shelf, just because we're a relatively fresh company. When we know that people want them, then we start building it.
Yeah, and just out of curiosity, what are the components you need to actually set up a network like this, right? So Qbert builds some of the parts. Eurofiber builds some of the parts, probably.
Yeah.
Is that it, or do you need more?
So for us, the way Qbert, what we envision ourselves is a manufacturer and provider of that network communication hardware, right? So that's what we're providing, and then we would like to provide this to either customers that want to use this or to organizations like Eurofiber who can integrate that into the rest of their network and then offer it as a service to other people. But the technology itself, the QKD, the quantum key distribution, that is only distributing the key, which then you want to have, as Mark was saying as well, some conventional networking that uses encryption and handles the rest of your data traffic.
Yeah, because you need to have something that creates the key and something that decrypts the key again at the other end. Mm-hmm. And is that possible with conventional hardware, or is that something that you need to invest in as well if you want to do that? Or is it something that Eurofiber does? Or?
A basic setup would probably consist of fiber optic cable between locations and an end node at every customer location that would connect into one of the hubs that Joshua already mentioned. A hub could be in a network, so you need a data center location and some customer connections, and then you're good to go to build this system and interact with more classic networking setups.
Okay, and a hub from Qbert, is that like a complete rack, or is it just one server, or?
It's a few rack units. That's right. Yeah, it's a few rack units, but can easily fit inside of a data.
It's not a full rack.
It's not a full rack. No,
but I think that's a very good point, because it's a hub spoke model, right? So everything has to go through one hub. So if you're talking about scaling towards the future, I can see the challenge there if you want to do everything via one hub. So it's not a mesh kind of setup yet. Is that possible towards the future, or is it, or will you? Is this the architecture?
It's very much possible towards the future, and actually that's what we're moving towards and developing towards as well. So making sure that not only many users can connect to a particular hub, but making sure that users can also be multi-homed, for instance, that there's different hubs and they have different options that they can connect to, and that hubs can route signals to each other. Yeah, exactly. So we move in this direction, and this is already one of the advantages. I think that Qbert has over other people that are working on QKD, for instance, is that we don't just target point-to-point links. We really go for, as you said, at the moment, hub and spoke, but then moving progressively more and more to just a full mesh network.
Yeah, well, you will have to probably if it
probably
if it really catches on. You will
exactly. Yeah.
And one of the things that we find particularly interesting is that this hub in the middle is actually not seeing data and not keeping the keys. So it's very independent. The end nodes use it for measurement and then generate key at the customer side of the setup. And we, as a network operator, we would not see keys or data traveling across these fibers. So it would be extra safe, and also very much aligns with our open network model.
Yeah. So the keys will only be visible at the beginning and at the end of the connection.
That's right.
Not anywhere in between.
That's right.
Yeah.
I wonder, since there is a limit to the distance, is there also a limit on the speed, on how fast it can be transferred?
It's light, so
Yeah, exactly. It's light. So I mean, it's the same light signal. So latency in the connection is about the same as you have in normal.
Okay,
Yeah.
but if Eurofiber has a 10 gig network, it transfers 10 gigs. It's not
It'll
limited to one because there's a new technology in it.
No, exactly. The data communication rate will still be the same as
Okay.
if you have a 10 gig connection, you will still have a 10 gig
Okay.
data connection as well.
Okay.
Yeah. Yeah.
I just wondered if it had impact on.
Well, it's a certain area of investigation because we need to validate this technology against what is typically available in fiber optic networking. So we need to consider SFPs and frequencies and all the stuff that you need to build a custom a regular fiber optic circuit. So it is definitely something that we have looked into, but it is very much compatible with the way we work. And it also allowed us for the setup to once we had it going in the data center to actually get it started, and it has been running stable since.
Okay.
And just getting back to the production readiness of it, what have been the findings during your testing of this, right? So what surprised you in terms of how hard it was, or what? So more or less, yeah. Like I said, what's been the striking findings in when you tested this?
Well, the first thing that we had to look at was the compatibility in a classic networking environment. Also brought us to some very specific solutions that we had to invent in this topology to test, and actually use a helium cooling device that we needed to set up in our data center, which is typically not allowed for extinguishing purposes.
Mm-hmm.
So we had a very close look at the form factor that this setup would require to function in regular environments. So once we got that out of the way, it sort of surprised us how easy it was and how seamlessly it seemed to integrate into the classic networking technology. And we've made some steps coming off a dark fiber and now sending these encrypted connections into our MPLS network, which is very much a next step, and it has been running seamlessly.
Yeah, for us, I mean, from the start, we recognized there is always going to be work and learnings whenever you integrate with other organizations. So we actually have software simulations of the system that are fully use the same software interfaces that another organization would use, and we can spin these up on servers back at home base at the office and let people test with them. So I mean, that's how we started, to be like, look, this is what it will look like, this is what the APIs will look like, this is what you'll see on your network. And only after we were quite comfortable there, then it was like, okay, now let's try with actual hardware. And then certainly also from our perspective, we learned a lot from Eurofiber about what it means to really install in the very sophisticated data centers that Eurofiber runs.
Yeah, I think the compatibility point you make is interesting, because I've attended several events in the past 5-6 months where they were talking about QKD and different vendors were involved in it. And so what's the is there any compatibility issue between different initiatives? So if somebody else like yourselves, another QBird, for example, says, well, we developed something as well, can you just say, well, we just plug it together and then everything will work? Or are there compatibility challenges in getting the maybe the bigger network rolled out? Because towards the future you want to scale up, right? So how does that work? Is it compatible? Is it a universal standard, for example?
There are a number of standards that are being developed in organizations like ETSI and the ITU, for instance. So I think the community has been thinking about this for some time and doing quite well, which is good. So from a user's perspective, or the interface towards like the equipment that would provide the secure communication data stream, these interfaces are well standardized, and I think everyone would use QBird, and certainly its competitors would use the same one. So that would be fine. From like a management perspective, management of the network, there's maybe some differences between the vendors, but we're all converging to the same overall structure and data models for how you manage these devices and manage the network.
Okay.
Yeah.
So, and what is the roadmap actually? Because there's also, apart from the likes of Eurofiber and Qbert, there is also sort of I think it's is it called a project or a foundation or something? A party that actually wants to promote this even further. I forgot the name. It's
I think you're hinting at quantum delta. Maybe?
Yes.
Yeah.
Yes.
Yeah.
That's it. Well, hinting, very subtly hinting, and then just displaying my ignorance on the topic. Yes, that's what I was thinking of. I forgot the name. But what's the role in of you guys in this general kind of approach, and what do we need to actually get to where we wanna be to roll it out as broadly as possible?
Well, that would be an entirely different episode, I guess.
Well, we'll be back next week.
There's a lot to unpack there. But we are now first from Eurofiber, because I cannot testify on the Delta initiative. They have been very accommodating in setting partnerships up, and they are an interesting ecosystem in and by itself. But from Eurofiber, we are now working with guys from Qbert to find various aspects of validating this technology to actually bring it to the market. And it is very much focusing in the roadmap on security targets that customers may have if they have demanding environments, like, for instance, in finance or in government or in healthcare, where you would be looking at very high security targets for data protection. We would be very much looking at certification of these, validating these security targets, and also propositioning the security aspects that the system can actually offer, and getting it certified and validated with industry partners to actually understand this and get it totally ready.
And is there any? I mean, I'm not asking you whether it's going to be finished by the 13th of March 2025 or something, but is there any clear path forward? When will we see fully production ready networks, and that are actually also deployed and getting traction in the market of this? Do you expect?
It's coming within a couple of years. This is definitely coming.
Is there interest from hyperscalers as well, or Equinix that has a very large network?
We've had talks with Equinix in the past on this topic. Yeah, there's some interest there on how things will actually work inside their network. Also, government agencies are interested in this. Port of Rotterdam, just talking in the Netherlands for a second, right, is also interested in deploying things. And then certainly the telco providers like Eurofiber as well.
Okay, that's good to know. You think there's also a good business case as long as the distance is staying at around 200 kilometers?
Yeah, well, definitely. It sort of ties into the way that we look at these topologies, and how many setups would we need to actually overcome these distance challenges. The guys from Qbert are still working on expanding these distances, so we're looking forward to that, and we are actually helping them within this project to find ways to optimize these fiber connections to actually introduce more length. And topology-wise, we are interested in configuring setups that would allow us to operate a network and actually connect any endpoint to wherever it may be in the Netherlands to a hub in the vicinity, and really get this any-to-any connection type going.
Yeah. So it's scalability. That's the
that is the key driver.
That's the key now, right?
Mm-hmm.
To get it actually completely finished. Or
yep.
It's never finished, probably, but.
Yeah, making it an affordable solution, because in itself, QKD technology is very expensive. If you want to start experimenting with it tomorrow, you could buy a full setup, but you'd be really investing. And in the way that we are now working together, we can find models that make it actually affordable for multiple companies to connect and have a more affordable business model.
Yeah. All right.
Yeah.
I hope this was clear, right?
Okay.
I thought it was clear, but I'm not sure what the listeners will think.
I think for many listeners this would have been a very clear, understandable podcast. So we'll see.
Is there anything that you would like to add in terms of what we didn't discuss, or is it all?
Did we forget to ask the most important thing?
I think the main thing is follow what we're doing. Look for Qbird. We're on LinkedIn and qbird.nl.
Oh, a pitch at the end.
Oh,
Sorry. Yeah.
Oh.
Do we get a Eurofiber pitch as well?
No, I don't have a pitch, but I do want to remind everyone that's actually interested in listening to this podcast. If you want to test with us and actually learn more about this subject, find us within Eurofiber or a Qbird team to actually continue this work.
So it is a pitch.
But that's sort of.
No, that's fine. I mean, at the end of the day, we want to keep. We want to know. We want the people who listen to this and the people who read us to understand technology better. So if that
And use it if possible, if needed, or whatever.
all right.
Okay, thank you.
Thank you very much.
Thank you.
Okay, so that was it for this episode. Thank you for listening. If you find it interesting, please share it with your friends and colleagues and maybe other people that might find this interesting. You can also subscribe to our podcast. That can be through Apple, Google, or Spotify, and many other services. Thank you for listening, and we'll see you next week.
TechZine Talks.
And don't forget to rate us on Apple or Spotify. We would love 5 stars.
Visit techzine.nl or techzine.eu. Don't forget to subscribe to this podcast.